I'll start a bit with the history of how we get to this idea. As a player developed a dynamic predictor for the Stina line ferries a couple of years ago, and for some years later in the efficiency project we think about how about exchanging this information. Right? I keep this information of predicted positions to ourselves, and I can share it to other vessels. So we developed a very simple user interface and tested this in React in the efficiency project, and verified, okay, for collision avoidance there's no need. It's too close and too late when you have the predicted positions. Anyway, think about further on, maybe when you need to operate close to ships. And one operation is maneuvering with the ship untagged. Nowadays the predictor is only taking the own ship's forces. Wind, aerodynamic forces, propeller, rudder, power thrusters, etc. But if you put on a tag, that forces does not come in, so it's they're a little bit complemented with data coming, but not exact. And the tag master do not see what's happening. He just see a big ship side and have no idea what is really happening. So that's what we want to test in ACCSEAS. We also want to make a more complete user interface. We have in efficiency, so we cooperate with the DMA and NAS and put this service into the ship EPD and test it in a simulator environment. And the predictor is used to plan the first and last minutes of voyage, when you leave and when you enter your berth. So it's not strategic, but it's tactical in the very last minutes. And how we will test this is in simulators, as I said, and we will have the tag masters and pilots maneuvering the ships to say what they like. We can also collect measurable data like time for operation and speed landing on berth and repeatability. For some examples, we can log on a lot of other data as well. And I think this will be of more use to when it's to get larger ships in smaller ports, and also if you develop this slow steaming vessels with very low engine power, it's even more important to know the tags. And we plan to do this testing later this year, probably before the summer, but we're not sure yet. And this is an example how it could look like when the dynamic predictor is in use. We see the green ship contours, that's the predicted positions. We also see the tag contours, which is small gray figures, and the red one is the total ship. This is from a commercial simulation we did last year for Rotterdam, so this is actually a real simulation done. And as I said, this predictor in the ship EPD, we have some 9 ratios left on the interface, but we are in good speed with Mats and Ole at DMA, and we're sure we will get this ready within the next couple of weeks. And we also, for testing and for comparing, made a very simple linear economic predictor, taking into account the speed and the accelerations in linear and rotational. This is our work plan. This second quarter of the year we will work with actually complete the project, and hopefully we might be report for the third quarter. And next ACCSEAS conference we will present this, and maybe also we can bring a demonstration of small simulator. That's not false. Here's our test plan as presented in the earlier in the reports. So it's no big deal. We have to test without predictor, of course, and then really different level of predictors with and without type forces. And also, if we have got the time, we will see we can use type commanding via graphical user interface. That's to avoid mistakes with voice communication. I will also take the time to present the other part we're doing in ACCSEAS. It's AI-based risk evaluation. It's actually quite simple but complicated. We do check what's the normal behavior of vessels in a square, quite small square. What's normal behavior here? If it's normal, that's statistical. So, this kind of vessel is normal behavior when it's not dangerous, and if it's not a normal behavior, when it comes to the warning on it. For a moment, the system is developed for VTS operators, could also be put on board ships later on. And here's a big picture of its not normal behavior. As you see, it's detected quite early, for a long time before we run ground. So that could actually be a really useful tool. And we have some basic conclusion on this. It's possible to find. And we tested on known accidents. And all known groundings were detected. And we also did some testing in fairways and found that ships choosing to sail on the port side of the fairway was detected as behaving abnormal. So, kind of detail. I think that's enough for me for now.